Chapter 5.2, Day 4, Rationalizing the Denominator. Properties of radicals. We already discussed these properties in the previous lesson, that in the product property you can have multiplication of two numbers and you can also separate them as for nth root of a times nth root of b, and or you can combine them into single radical. So in this case you have cube root of 8 and that's going to be 2. For the quotient property you can separate them into different radical symbols, or you can combine them into one radical sign. 162 divided by 2 is going to be 81, and fourth root of 81 is 3. Now we are going to discuss that there should be no radical appear in the denominator of fraction. We are particularly discussing the third property here, and we are going to take the help of example to remove the radicand from the denominator if the numbers or the expression is in a fraction form. Example number 3, writing radicals in simplest form. We can write the fraction into a simplest form. The first thing you want to do it always is to remove the radicand or the radical symbol from the bottom. Step number 1, can you divide using the quotient property, or you can simplify the denominator to get rid of the radical? Let's see if we can do that. So we can combine them into one radical symbol and we can try and reduce the fraction if we can, but here we cannot reduce the fraction. So first the step number 1 is no, we cannot reduce the fraction. Now we are going to find the prime factorization of the radicand in the denominator. So in the denominator we have is 8, and the factors are going to be 2 times 2. Now we are going to try and find out the fifth root of 8, which we don't have. So what we're going to do it now is make them in 5 in numbers. So if we have 2 times 2 times 2, and if we have 2 more 2's, then we can make them a group of 5 and get rid of the 1/5 root from outside. So to do that we are going to multiply it with big 1, and which means is that we are going to use the 1 as we're going to multiply top and bottom with the same number, and that's going to be 2 times 2, fifth root of 2 times 2. So we are multiplying top and bottom with the same number, so that when they cancel each other is just 1. So multiplying 1 to any equation is not going to change the equation, so we can multiply any equation by 1, or in other words we can multiply top and bottom same thing. It's not gonna affect our equation. Now we have on the bottom, so on the top what we have is 7 times 2 times 2, because we can combine them, and on the bottom we have is 2 times 2 times 2 times 2 times 2 times 2. So there are 5 in numbers. There were 3 already from the 8, and then 2 of them we multiply top and bottom. So their total number of 2's are 5. They make a group of 5, so it's cancelled from the fifth root. On the top you have is 7 times 2 times 2 is 28, and on the bottom you have just 2. So the answer is going to be 28, fifth root of 28 divided by 2. Our aim is to get rid of the radicand from the bottom. So in this way we do not have a radical symbol on the bottom. For number 1, first of all you're going to try and reduce 19 divided by 4 if you can. but they are not on the same table, so we cannot reduce them. Now we are going to make the prime factors for the denominator. So I'm going to rewrite it as fourth root of 19 on the top, and then there is fourth root of 4, that is 2 times 2. Now we need 2 more 2's so that we can take this out from the radical symbol. So we're going to multiply the same to top and bottom. So we're going to multiply 2 times 2, fourth root of 2 times 2 on the top, and fourth root of 2 times 2 on the bottom. So the number of 2's we're going to have on the bottom is going to be 4. And then if they make a group of 4, then they can take out or get out from the radical symbol. And in this case, they make a group of 4 here. So they get out of the radical symbol, free from the radical symbol. And on the top, you're going to multiply 19 times 2 times 2. And that's going to give us 76. Now we can see that there is no radical symbol on the bottom, so that is your right answer. Next, we are going to separate the two radical symbols, and we are going to make factors for 4, and that's going to be 2 times 2. In order to get this one out of the radical symbol, we need 3 more 2's. So we are going to multiply the top and bottom with 3 to fifth root of 8, in other words. So we're going to multiply 2 times 2 times 2, top and bottom. And what we get on the top is going to be fifth root of 3 times 2 times 2 times 2. And on the bottom, you're going to get here is fifth root of 2 times 2 times 2 times 2 times 2. So that's 1, 2, 3, 4, 5. Now they make a group of 5. So it means they can get out of the radical symbol. And then your answer is going to be 2 on the bottom. And on the top, you can multiply all the numbers together. So 3 times 2 times 2 times 2. And that's going to be 24. So our answer is fifth root of 24 divided by 2. And we removed the radical symbol from the bottom. For square root, you just have to multiply one number top and bottom. So you have a square root 6 on the bottom. To remove the square root, you're going to multiply and divide with same number. And on the top, you get 2 times square root 6. And on the bottom, you get is 6. Now you can reduce them, and you can get here is 2 divided by 6. That's going to be 3 on the bottom. So square root 6 divided by 3. And for the next one, you're going to multiply top and bottom with square root 11. So you got here is 5 square root 11 on the top, and on the bottom you get is 11 times 11. Make a pair, get out of the radical. So you got 5 square root 11 divided by 11. For the next one is the cube root, and you can factor the bottom number. So you got here is 3 times 3, and in the cap is 3. So in order to get out of the radical symbol, we need 3 times 3 times 3. We have 2 3's already, and we need one more 3. So we're going to multiply top and bottom with one more 3. So cube root of 3. So whatever we need, we just multiply top and bottom. So on the top, we got here is 3 cube root 3. 3 cube root 3. On the bottom, we have cube root of 3 times 3 times 3. They make a group of 3. Get out of the radical symbol. So our answer is 3 cube root 3. and on the bottom is just 3. You can cancel this 3 and 3, and answer is cube root of 3. Next is 8 divided by cube root of 49. So we can factor the bottom, 7 times 7. We need one more 7, so we are going to multiply top and bottom with one more 7. What we get here on the top is 8 times cube root of 7. On the bottom we got 7 times 7 times 7. They make a group of 3, so they get out of the radical symbol. Our final answer is 8 cube root of 7 divided by 7. Next we are going to do the fourth root. So first thing always is to do is factor the bottom, and we have here is 2 times 2 times 2. And in the cap we have 4. If we have one more 2 here, then we can take out this 2 from the radical symbol. So to have one more 2, you're going to multiply and divide by 2. On the top I get here is 5 times 4th root 2. And on the bottom I got here is 2 times 2 times 2 times 2, 4th root. And they make a group of 4. So it means they get out of a radical symbol. So here is 5 4th root of 2 divided by 2. So that's the 4th root. Next is we need 4 of the same numbers. So we have already 5 times 5 times 5. We need one more 5, so we're going to multiply and divide with that 5. On the top you got 2 4th root of 5. On the bottom you make 4 5, so they get out of the radical symbol. So answer is just 5 on the bottom. For a denominator that is sum or difference involving square roots, like a sum or difference involving square roots, multiply both the numerator and denominator by the conjugate of the denominator. The expression a square root b plus c square root d and a square root b minus c square root d are called conjugate of each other. So if you have a square root term like that, if you change the sign of the center term and make the positive to negative, then they become conjugate of each other, where a, b, c, and d are rational numbers. So let's do example number 4 and see how we can remove the radical symbol from the bottom by using conjugates. So now I'm going to rewrite this problem, 2 over 5 plus square root 3, and I'm going to multiply its conjugate on top and bottom. So the conjugate of 5 plus square root 3 is 5 minus square root 3, and I'm going to multiply it on top and bottom. On the top you get is 2 times 5 minus square root 3. And on the bottom you can apply the method here. So you can think like a plus b times a minus b, and that's going to be a square minus b square. On the top you're going to do the distribution, and what you get here is 10 minus 2 times square root 3. And on the bottom you got is 25, square root and square cancel. You got 25 minus 3. So you got here is 10 minus 2 square root 3, and then on the bottom you have is 22. Now I noticed that if I kept this term without distribution would be much better. So I'm gonna rewrite this again like that so that I can reduce it. So see what I'm trying to say here is that I'm trying to say that I'm going to write this as the same way I had it before. Now I can reduce the 2 and 22. So 2 and 22. So the answer is 5 minus square root 3 over 11. So what we can do sometime is that we can decide which way of writing is better so that we can simplify it more and it's easier for us to simplify. So that's why this 10 minus 2 square root 3, I went back and write it in this form, and then I could reduce the 2 over 22. Now to solve number 9, you're going to multiply top and bottom with its conjugate, and that's going to be 6 plus square root 2 on the top and 6 plus square root 2 on the bottom. So you're going to technically multiplying it with 1 because when they cancel each other, it's just a 1. On the top, what you have is 3 times 6 plus square root 2. And on the bottom is a minus b times a plus b. So it's going to be 6 square minus square root 2 square. And you got on the top is 3 times 6 plus square root 2. And on the bottom you got 36 minus 2. So the square root and square cancel. Now you can see that I left this one as it is. I didn't distribute because I want to make sure that what I got on the bottom is not reducible. And if it is not reducible, I will distribute. Otherwise, I will reduce these two numbers. So I got here is 3 times 6 plus square root 2. On the bottom I got is 34. So I cannot reduce 3 and 34 because they are not on the same table. So I will distribute the 3 inside. So which I got here is 18 plus 3 square root 2 divided by 34. And that's going to be your final answer. And you can see that by doing this step, we remove the radical symbol that we had it on the bottom, and we have just a simple number.